All right, everyone, we're now going to move on to the next part of this unit. And this is the last part that we're learning in this. And you're going to see this is identical to what we were just doing with equations. So I am going to go through this video kind of fast. And this video is just going over a bunch of problems. We're going to do 8 problems together in this video just to show you the different types that you can have for this. And you'll see these are identical to how we would solve for equations. We just have to just remember that one rule when we're dividing or multiplying both sides by a negative number, right? And that's a key thing, both sides, because now we're going to start doing problems where we are simplifying, and when we're simplifying, we're going to distribute a negative number. But since that's not being done to both sides to isolate and solve, we don't flip them. Right? We only flip when we are isolating or multiplying both sides by the same negative number to undo something that's being done to our variable. All right, so we're going to focus on multi-step inequalities. And our learning objective is you'll be able to solve multi-step inequalities. You guys already showed me you can do this with equations. So now we just need to go ahead and do it with inequalities. So let's just go ahead and get started through these problems. All right, so for this first one, remember, just like you would when you are solving an equation, we need to undo what's being done to our variable. So we do our PEMDAS in reverse. So that means I look and see, well, I'm getting subtractions being done to it and multiplication. So I need to get rid of my subtraction first, and I can do that by adding 7 to both sides. So now I have 5w is less than 35. And then to isolate that w, I'll divide each side by 5 to get rid of my multiplication. And now w is less than 7. All right, I'm not going to go through graphing for this video because we've already been doing it, but you would need to be able to graph these as well when you are solving these. All right, but I just want this video to be as short as it can be since we've already learned this, and I don't want to make you spend too much time, but just seeing how it is identical to equations except for that one rule. All right, and remember though, our solution for this is any number that is less than 7. So 6.999999 all the way down to negative infinity would work as a solution. All right, so for this one, the problem that a lot of students have with this is they see this minus sign, so they say, oh, okay, this 10 is being subtracted. But this is a positive 10. I could rewrite this as negative 3x plus 10 if I really wanted to. And then you could clearly see that this is an addition. All right, but so when we're doing this, we know that we're having addition is being done and multiplication. So same thing, we need to get rid of our addition first, and we can do that through subtraction. Even though I see the minus sign on both sides here, subtraction doesn't make us flip our inequality. It's only multiplying or dividing when it does. So now it's less than or equal to 45. And now I need to get rid of the multiplication, and I can do that through division. So that cancels. And now since I saw I divided both sides by that negative number, I need to remember to flip my inequality. So x is now actually greater than or equal to negative 15. All right, let's go ahead and move on to the next problem. All right, so for this problem number 3 here, even though they don't have it there, we understand that this is a parentheses, because when it's written like that fully in our numerator, if we were to plug in a value for x, we would have to multiply and add first before dividing. So that's telling us that that is considered a parentheses. So this is 2x plus 4 over 6. So remember, fraction bar we can think of as division. So to get rid of division, we're going to multiply. So first we would need to multiply both sides by the 6. All right, they cancel out. So now I'm left with 2x plus 4 is less than or equal to negative 24. And now that I got rid of that fraction, now I need to go ahead and say, okay, well, we're multiplying and we're adding here. So I'll get rid of the addition first. So 2x is less than or equal to negative 28. And now I'm going to divide both sides by 2. Even though I see the negative here, that's not what I'm dividing by, so I do not need to flip. And negative 28 divided by 2 is negative 14. All right, so those are going through some of just regular two-step equations and not really worrying about simplifying anything before. So for all of those, we just went straight into it and started to solve. All right, now we're going to start finding problems that we need to simplify first. So our rules when we're solving inequalities doesn't change for equations. We always look to simplify. So in the other ones, there was nothing to combine like terms, or there was no distribution that needed to happen. But now that I see this parentheses, I know, okay, well, that's telling me I need to multiply first. So now I have 24 minus 6y is less than or equal to. So I'm distributing this negative in. So this gives me positive 24y plus 24. Now, you might look at this and say, well, we're multiplying by negative. Why aren't we flipping the inequality? We need to multiply both sides by that negative. If we're just simplifying one side, then that doesn't change our inequality because we're not changing both sides of the numbers. So we're not looking at it any differently, meaning we're not jumping to the other side of the number line because we're only multiplying or simplifying that one side of the inequality. It must be the same number on both, and it must be when you're trying to do your inverse operations to undo what's being done to our variable. All right, so now from here, we're going to go ahead and move our variables to one side. I like to always move my variables, especially with inequalities, to my left. So I'm going to subtract 24y from both sides, and it's the same rules as before. They cancel each other out to 0. So now I have 24 minus 30y is less than or equal to 24. All right, now this is an addition, so I have an addition and multiplications being done. So I'll subtract 24 from both sides. Well, 24 minus 24 is 0. A common mistake here is people see something zeroed out and they're like, oh, okay, that means that this is no solution or infinitely many. But that's not the case for this, because we're saying negative 30y is less than or equal to 0. So now we need to go ahead and say, okay, well, if I'm going to isolate my y, I need to divide both sides by negative 30. And now I am dividing by a negative number to isolate my variable. Therefore, I need to flip my inequality, and this is actually that y is greater than or equal to 0. All right, we have 4 more questions that we're going to go through together. All right, so for number 5 here, same thing. All right, let's identify what's being done. Well, we're adding and now we're dividing. So to get rid of our addition, we'll subtract both sides by 10. So negative x over 4 is less than 13. All right, then to get rid of this division, we're going to go ahead and multiply. But since it's a negative x over 4, we're going to multiply by negative 4. This will cancel out the 4 and the negative. So we have x. We multiply both sides by a negative, so we need to flip our inequality. And 13 times negative 4 is going to give me negative 52. And that will be our final answer. Okay. Now, this one, we do have some things that we need to simplify first. We have multiple parentheses, so I'm going to go ahead and distribute this in. So negative 2 times 5 is negative 10, and negative 2 times negative 3x is positive 6x. Negative 6 times x is negative 6x, and negative 6 times positive 6 is minus 36, is less than or equal to negative 24. So not only do we have to distribute, but we also have like terms here. So I have this 6x and negative 6x, and I have this negative 10 and negative 36. So I need to combine all of my like terms. Well, 6x minus 6x is 0. They cancel out completely. So now I no longer have any x's. Right? Remember, you don't write 0x because 0 times any number is equal to 0. So we don't have to write that variable anymore. It no longer exists because it's zeroed out. All right, now we have negative 10 minus 36 is negative 46. So now we just need to ask ourselves, whoa, wait a minute. All of our variables got eliminated. And now we just have this statement, just like we did with an equation. If we had a true statement with an equation where negative 5 was equal to negative 5, and it was true, that told us infinitely many. And if we had a false statement, negative 5 is equal to negative 6, well, that's not true. That gave us no solution. The same thought process happens here with inequalities. So when your variable cancels out, it's the same thing that we were doing before. Is this true or is this false? Well, negative 24 is greater than negative 46, so it is true. But remember, that's not your answer. That's what leads to our answer. And our answer in this case would also be infinitely many. All right, so when your variables cancel out, it's the same thought process as equations. So that's why if you were able to solve the equations, then you're able to solve the inequalities. It's the same thing. There's just that one rule of multiplying or dividing both sides by negative. All right, but everything else is identical. It's the same thought process, especially when your variables cancel out. All right, now these are our last 2 problems that we're going to do. So once again, here I see, okay, well, I have this parentheses, so I need to distribute this first. So I have 8b minus 13 is greater than, well, 4 times 2b is 8b, and 4 times negative 3 is negative 12. So now I'm going to move my variables to the left-hand side, so I'll subtract 8b from both sides. Now, when this happens, they both zero out. So now I'm left with negative 13 is greater than negative 12. Well, is that a true statement? No, that one is false. Negative 12 is greater than negative 13. So remember, the false isn't your answer. It's what leads to your answer, and that means that this is no solution. So there is no value of x that we plug in will ever make this expression greater than the one on the right-hand side. All right, so it's the exact same thing that we were just doing before. All right, and then the last question that we're going to do, well, we have variables on both sides, so we need to start moving them to the same side. So I'm going to move them to the left by subtracting 5m. Well, 3m minus 5m is negative 2m. So now I'm left with negative 2m minus 8 is less than negative 30. All right, now once I put my variable on one side, I now need to start isolating it. So I see I'm multiplying and I'm subtracting. So I need to get rid of the subtracting first by adding it. So that gives me negative 2m is less than negative 22. And our last step would then be getting rid of our multiplication, which is through division, and they cancel. And remember, since we're dividing both sides by negative, I need to flip my inequality, and negative 22 divided by negative 2 is positive 11. All right, this is your answer, or this is your the end of your video. You would have to graph all these. The only ones that you can't graph are the no solutions and infinitely many. You don't graph those, but all these other ones you would be expected to graph as you're solving them. All right, that is it for this video.